Anil Kumar sharing with you a test question on prime factorization. The question is, the prime factorization of a number is 2 square times 3 square times 5. How many factors will this number have? You are given 4 choices, 12, 18, 30, 180. You can pause the video, answer the question, and then look into my suggestions. Now what we are given here is some number whose prime factorization is 2 square times 3 square times 5. We can always get this number by multiplying these terms, right? So 2 square is 4. Basically the factors are 2 times 2 times 3 times 3 times 5, correct? So the number could always be written as 2 times 2, 4, 4 times 5, 20, times 9 as 180. What we need to know actually is how many factors will this number have. So we have to find number of factors, not the number. So this is not the answer, okay? Number of factors. How will you find number of factors? Well, we'll actually take up this example, physically find all the factors, but here is how you can calculate. Here is the shortcut to answer. Since we have two 2's, we have an option of selecting either one of them or both of them or none of them, right? So the number of factors will be, you can find number of factors by multiplying how many options do we have for 2's. We have 2 plus 1, 3 options. So we could multiply number of ways of choosing 2 is 3. Number of ways of choosing 3 is, we have 2. So we may or may not select 3 also. So 3. There's only one 5. Either you select 5 or you don't select 5. So we have 2 ways here, right? So that is the total number of options, 9 times 2 as 18. So the answer here is B, which is 18. Let me show you how we will actually list all the 18 factors, okay? So that will give you insight to it. I hope you have understood how we got the answer. So let me take this question once again. This time I've kind of modified this question. The question here is, write all factors of a number with prime factors as 2 square times 3 square times 5, right? So we know that the number is 2 times 2 times 3 times 3 times 5, and we know this number is 4 times 9 times 5. So 20 times 9, 180. Now let us see how to list all the factors. Well, of course, one of the factors will be 1, correct? So one of the factors is 1, and we know 180 will also be a factor. So let me write 1 and 180 here. Now to get other factors, what can we do? Now let's start. We have 2 2's. We could choose one of them or none of them. So if I don't choose any of these numbers, I get 1 as my factor, since 1 is always a factor. If I choose all of them, I get 180. So I got these 2. Now I have an option. I can take 1, 2, so 2 is my factor. I can take 2 2's, so 2 times 2, 4 is my factor. Then I can multiply this 2 by 3, so that is to say 2 times 3, which is 6, is my factor. I can multiply by these 2 with 3, so 4 times 3 is 12 as my factor, correct? So we're taking care of this. Now we can multiply both these 2's with both these 3's, right? So, or let's do 1 2 with 2 3's. So 1 2 with 2 3's will be 9 times 2, 18. Now twice that will give us 36. Right. So what we have done here is that we had an option of choosing 2's. We chose 1 or we could choose 2. Similarly for 3, we chose 1, we could choose both of them. And now we'll do with 5. So when I do with 2 with 5, I get 10. 4 with 5, I get 20, right? I could multiply 5 with 3, which is 15. And I could multiply 5 with 6, which is 30, right? Now, we could multiply 5 with these combinations, correct? So 2 times 2, which is 4. 4 times 3, which is 12. 12 times 5 gives us 60. So we get 60 as another option. Now, let us take combinations with 3s. So if I take both 3 together, right, both 3, then both 3 means 9. 9 times 5 is 45. And when we multiply 45 by 2, taking this 2, we get 90 as another factor. So that is how we could actually build on the factors, right? Now we can also take the individual numbers 3 and 5, right? So 3 is left, 5 is left, and the combination 3 times 3, which is 9. So that gives us 18 factors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, the alternate way could have been by making a kind of factor tree, right? So let's do that. So we could do 1 times 180, right? And then it is 2 times half of this, which is 90. 3 times, if I divide by 3, it gives us 60. 4 times, since 2 times 2 is 4, we could do half of 90, which is 45. And 5 times, if I divide this by 5, I get 5 times 3, so and 30, which is 36. Now we can move forward. We can say 6 times, dividing by 6, we get 30. 7, 8, 8 is not a multiple, 9 is a multiple, 3 times 3. So if I divide by 9, I get 20. And then I could divide by 10 to get 18. By 12, we can divide 12 times 15, will give us this particular number. So we could get this particular list. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So these are all factors of 180, correct? So as you can confirm that there are 18 factors of 180. And as we showed you, the reason is that we have 2 2s, we could have 1 2, 2 2, or no 2 at all. So that means there are 3 options for 2s. Similarly with 3, we have 3 options. We may take a 3, we may not take both the 3s, but just one. So we may take 1 3, 2 3, or none of them. So there are 3 options for 3. With 5, we could take 5, getting the factor 5, or we need not take a 5. So that is also an option. So there are 3 times 3 times 2 number of options, which gives us 18. So I hope now you understand that even without listing the factors, we can know how many factors will a number have if we know its prime factors. Perfect. So that's the whole idea. So I hope it makes sense. So that brings us back to our original question. And I hope the shortcut method which we've done to solve this particular question is absolutely clear. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.